There are billions of stars and many more planets in our galaxy. It will take humanity millions of years to register and get to at least some of them. However, you need to start somewhere before. Welcome to the Techno channel, and today you will learn about 5 exoplanets on which life is possible. Kepler-62f. A group of researchers led by specialists from the University of California, Los Angeles, USA, came to the conclusion that life could theoretically exist on the exoplanet Kepler-62f. The Kepler-62f object was discovered in 2013, near the orange dwarf Kepler-62. The observations were carried out using the Kepler telescope, which registers periodic changes in the brightness of stars caused by transits of the planet in front of the disk of its luminary. The exoplanet Kepler-62f is located at a distance of approximately 1,200 light-years from Earth. This object is about 40% larger than our planet in size. The age is estimated at 7.5 billion years. Scientists used to say that the exoplanet is located in the habitable zone of its star, that is, it may be suitable for the origin of life. Now the results of computer modeling speak in favor of this. Experts simulated conditions on Kepler-62f, in which the thickness of the atmosphere varied from 1 to 12 terrestrial. In addition, various concentrations of carbon dioxide were studied from similar to Earth's to exceeding it by 2,500 times. It turned out that in many scenarios, pools of water in liquid form can exist on the surface of an exoplanet, which means that there may be life on Kepler-62f. Gliese 667 cubic centimeters. The planet was discovered in 2011. It orbits the red dwarf Gliese 667, in a triple star system located just 24 light-years from Earth. The approximate mass of the exoplanet is 3.8 times the mass of the Earth. However, scientists have no idea what size Gliese 667 cubic centimeters is. It is not possible to find out, because the planet does not pass in front of the star, which would allow calculating its radius. The orbital period is 28 days. It is located in the habitable zone of its cold star, but almost certainly the planet is captured in an orbital rotational resonance and turned to its own side only with one side. If the inclination of the orbit is not too small and accordingly, the mass is not too large, then the greenhouse effect created by a sufficiently dense atmosphere may well create sufficiently comfortable conditions on the surface of the planet for the existence of primitive forms of life. Kepler-438b. Discovered in 2015, this planet orbits a red dwarf star, much smaller and colder than our Sun, and has a radius only 12% larger than Earth's. The star itself is located about 470 light-years from Earth. The planet makes a complete revolution in 35 days. It is located in the habitable zone, a space inside its system where it is not too hot and at the same time not too cold to maintain the presence of water in liquid form on the surface of the planet. As in the case of other discovered exoplanets orbiting small stars, the mass of this exoplanet has not been studied. However, if this planet has a rocky surface, then its mass may be only 1.4 times larger than Earth's, and the temperature on the surface varies from 0 to 60 degrees Celsius. Kepler-452b. This planet was discovered in 2015 and became the first potentially discovered Earth. A similar planet located in the habitable zone and orbiting a star similar to our Sun. The radius of the planet is about 1.6 times the radius of the Earth. The planet makes a complete revolution around its home star, which is about 1,400 light-years away, in 385 days. Since the star is too far away and its light is not too bright, scientists cannot measure the gravitational effect of Kepler-452b and, as a result, find out the mass of the planet. There is only an assumption that the mass of the exoplanet is about 5 times the mass of the Earth. With such a mass, the gravity on the planet is about 1/8800th of a time greater than on Earth. Its size is too large to consist almost entirely of heavy elements by analogy with the Earth, but with a probability of 49 to 62% it can be a solid-state planet. At the same time, the temperature on its surface, according to approximate estimates, can vary from -20 to +10 degrees Celsius. Proxima Centauri b. On August 24, 2016, the staff of the European Southern Observatory announced the discovery of the Earth-type exoplanet closest to the Sun, Proxima Centauri b. It orbits the red dwarf Proxima Centauri, whose distance from the Sun is about 4.2 light-years or 40 trillion kilometers. The minimum mass of Proxima Centauri b is equal to 1.3 Earth masses. If we assume that the planet has a rocky composition and a density equal to the density of the Earth, then its minimum radius will be equal to 1.1 Earth radii. Proxima b is the closest known exoplanet and at the same time the closest exoplanet located in the habitable zone. The planet rotates at a distance of about 7 million kilometers from Proxima Centauri with a period of 11.2 Earth days. Despite such a close distance due to the weak luminosity of the star, the planet receives just enough heat so that the water on its surface can exist as a liquid and not freeze into eternal ice. It is not yet clear whether the new exoplanets have an atmosphere, since Proxima b receives X-rays 400 times higher than what we have on Earth, and this can lead to the atmosphere volatilizing away. 2 expeditions to the Centauri system are already planned for the next 50 years. As part of both programs, the Centauri system plans to launch probes that could transmit photo and video information to Earth. And most likely, in the coming centuries, Proxima b will become the most studied exoplanet of the Earth type, which will bring closer the solution of the main question of humanity. Are we alone in the universe? That's all, friends. Support us with likes if you liked this video, and also subscribe to the channel so as not to miss new videos. Bye.